Hello, today in this video I will be explaining how to perform slicing of 2D images and saving them as a video using Python code in Emulatics preclinical software. Python Menu is a useful tool that helps you run your own scripts for your projects. In this tutorial, I'll be using the CT spec scan of a mouse which was injected with 3 traces and explain in detail the Python script. The goal of this Python script is to generate a certain number of 2D slices and save them as PNG files. We then use the PNG files to create a video of desired length. For this demonstration, we'll be extracting underlay images as well as segmentation masks into separate folders. Now, let's dive into the script. In the constructor of this class, we initialize the output image dimensions, namely the width, height, as well as the number of samples to be taken. Start and end corresponds to the z-axis of the 2D slices in world dimension, which can be obtained from the Emulatics preclinical software by clicking Slice Through option to get to the first and the last slice and noting the z value. We define two functions to create our dataset. The first function, getImageSlices, is used to obtain 2D slices of the underlay without any segmentation or overlay in it. In this function, we first set the destination path to save images. We then translate the center of the empty canvas, which will later be used to obtain the affine matrix. Next, we set the underlay and remove all overlays and segmentation masks. In the for loop, we obtain the current x and y viewing center and modify only the z value using the samples variable we created before. The draw method used in this Python script captures the 2D image from the Emulatics preclinical software and saves it to the image variable defined in the constructor. The draw method requires an image canvas variable to store the image values as well as an affine matrix to map the 2D images to the center of the image canvas. This matrix can be obtained by multiplying the center to image matrix with the world to view matrix. Upon completion of the draw method, the image is loaded to the image canvas. We can perform operations using NumPy. As shown here, we first convert the image canvas to the NumPy array and then transform the image from BGR space to RGB space. Now, the self.image variable can be used to store the data as a PNG file. Similarly, the next function, getSegmentationSlices, can be used to obtain segmentation slices and store them in a separate folder. The method is similar to the above mentioned function, except we set showSegmentation variable to true, whereas we set showUnderlay and showOverlay to false. The function createMovie can be used to create a video in MP4 format from the underlay and segmentation slices we created before. It is also possible to provide the FPS or total duration to this function. The last function, reinitializeView, is used for resetting the view to default view with underlay, overlay, and segmentation turned on. Now let's execute the Python script. The code can be found by clicking on Tutorials, Python, Slice Video 2D, and clicking on the Info button. Before we execute the script, we need to load the example data. That can be obtained by clicking on this Load Example Dataset button. Next, we can enable the 3D view by clicking 3D option as shown here. Now let's execute the script. In order to do that, we click the Python button in the menu and then Run Script and select our Python script. Upon clicking Open, we should be able to execute the script. We can see the progress of our script in the 2D view. Now let's wait for some time for the Python script to complete its execution. After execution, you should be able to see the saved images in the respective folder. The final video that is obtained from the saved images can be found as shown in the location here. As we go here, we now have a nice video containing the slices of the 2D images. This script and tutorial can be used as reference to implement your own logic to extract 2D slices with various configurations. This functionality, for example, can also be used for performing the image processing operation on 2D slices or generating image and mask dataset to train a 2D deep neural network models. With that, we have come to the end of this tutorial. Thank you for listening to this tutorial. If you have any questions, please feel free to contact us. Our contact information can be found on our website. Have a nice day. Bye.